First of all, a very good evening to one another. Let me introduce myself. Myself, Dishwan. I am from the Department of Electronics and the Communication Engineering. I am pursuing my graduation in the Srinivasa Raman Institute of Technology. Today, we will discuss about the what are the Verilog design of latches and the flip flops in the digital circuits and the design. So, first of all, the introduction to the Verilog design of latches and the flip-flops. This representation provides a particular overview of designing the latches and the flip-flops using the Verilog, and understanding these sequential elements is essential for digital circuit design, and Verilog offers a powerful way to model and simulate their behavior articulately. So in this block diagram, we can observe the inputs and the outputs and the clock and set the reset. So we can observe this in this diagram. So and then the next is the basic concepts of the latches and the flip-flops. Generally, we know that the latches are level sensitive devices that stores the data based on the input levels, and whereas in the flip-flops are edge triggered devices that capture the data on clock transitions, and both are fundamental building blocks for sequential logic circuits. So here is a sum of the future latch and the flip flop. If you take the triggering in latch, the level sensitive changes with input when enabled, whereas in the flip flop, the edge sensitive changes only on the clock edge, whereas in the future of behavior, it is continuously responsible while enabled in the latch, and it is responsible only at the specific clock transitions. And then the next feature is typal use, the combinational logic and specific multi-phase clocking, whereas in the uh, sequential logic and the counters. The another feature is Verilog modeling. We use this code always block use with caching. And then the next is the types of latches and the flip flops. So commonly the latch types include SR, D and the gated latches. Typically the flip-flops include D, T, JK and SR flip-flops. Selecting the right type depends on the specific timing and the control requirements. So first of all, the types of latches. So first of all, the types of latches means the first one is the SR. It means SR latch. SR latch means basically it is set reset reset latch. Basic latch with the two inputs set and reset that control the output. The next latch is gated SR latch. SR latch with an enable signal allowing the latch to respond only when enabled. The next is delatch. Delatch means data or delay. Simplifies SR latch by having a single data input and enable signal. And gated delatch. A D latch controlled by an enable signal, JK latch. It is similar to SR latch but without invalid states. The next is T latch. It changes state when the input toggle is. The next is a types of flip flops. Types of flip flops mainly and the SR, D flip flops, JK, and the T flip flops. First, we can discuss about the SR flip flop. It has a set on the reset inputs and it changes state on clock edges. And then the next is D flip flop. D flip flop means it captures the value of the data input at a clock edge and holds it. And then next is JK flip flop. JK flip flop means a flip flop that acts as a SR flip flop without invalid states. The next is T flip flop. T flip flop means it states with each clock pulse when the input is high and variations exit for active high or low inputs are different clock edges. The next is Verilog modeling principles. So the Verilog models describe the hardware behavior using models, signals, and the processes. So the behavior, the data flow, and the structural molding styles are used for design. The proper understanding of timing controls is crucial for accurate modeling. The next is modeling a latch in Verilog. Latch in Verilog. The latch is level sensitive and can be modulated using always blocks and with a level sensitive condition. And use of non-blocking assignments ensures the correct simulation behavior, and proper initialization of signals is necessary for predictable operation. Basically, the latch means here is the block diagram and the truth table. So in this truth table, the SR and the Q bar. So if you give the inputs as 0 0, the Q and Q bar are latch. If you give the 0 1, so the Q value as 0 and Q bar is 1. If you give the S as 1 and R is 1, the Q, so the output as Q as 1 and Q dash is 0. And the next is if you give the inputs as 1 1, so the Q and Q bar is meta, meta, metastable. So the next is Verilog code for a delatch. So the Verilog code for a delatch. An example code for a snippet demonstrates modeling a delatch with an enable signal. The latch captures input data when essential is high and holds it otherwhere. So the comments in code help clarity the behavior and understand. So here is the waveform of the delatch. You can observe the next is modeling a D flip flop in Verilog. So it is the main concept in the latches. So the modeling of a D latch in the Verilog. So the D flip flops are modeled using a always blocks and triggered on clock edges. On the positive edge is triggered flip-flops capture data on rising the clock edges. Non-blocking assignments are used to reflect the hardware behavior and articulating. The next is Verilog code for a D flip-flop. So the example code shows the use of always block for a D flip-flop. The data input is sampled on the rising edge of the clock, and the reset and the enable signals can be added for the more complex models. So you can observe the code, the Verilog code for a D flip-flop. Here is a code, the data input, the clock input, and the output queue. And then the list is and then next is the uh, Asynchronous reset in flip-flops. The asynchronous reset allows the intimate clearing of a flip-flop output regardless of clock. The Verilog models include the reset signals in the sensitively list for a asynchronous behavior, and a proper reset handling ensures the enable startup and the operation. So here is a block diagram of the asynchronous reset in the flip-flops. Asynchronous active low reset D flip-flop. The input are the D and the clock, and the output as Q. You can observe. And the synchronous reset in the flip-flops. The synchronous reset is controlled by a clock edges and integrating reset logic into main process. This uh, this approach uh, prevents relicence and ensures the predictable reset behavior. And Verilog models include the reset signals within the clocked always blocks. So here is the asynchronous active low reset D flip-flop diagram. So the next is the timing and the simulation uh, considerations. So the Verilog simulation helps verify the correct latch and the flip-flop behavior before the hardware implementation. So the before the hardware implementation, so it can verify the correct latch and the Verilog behavior, and the proper use of delays and the timing controls is essential for accurate modeling, and the test benches are used to estimate the inputs and the observe the outputs under the various conditions. So here are the some of the abstract and the fundament and the functional simulation and the timing simulation. So the abstracts are the timing delays, purpose, state, speed, ritual issues. So the next one is the common design pitfalls and the solutions. So the avoid and integrated latch inferences by the ensuring that signals are fully uh, assigned in all conditional branches. Use non-blocking assignments for sequential logic to prevent race conditions, and proper reset handling is crucial to prevent the metal stability and undefined states. So here are the some of the missing uh, begin end and the missing semicolon and the accidental assignment and the incomplete sincerity list and the various lists and the assignments in the multi always blocks. It means the always blocks are concurrent with some with one another. So a Verilog should not be assigned a value in more than one always blocks. And then the last seventh one is the blocking and non-blocking assignment.